All right, welcome back to the deep dive. Today we're doing something a little bit different. We're going to try and tackle research methodology and statistics.
Ooh, sounds intense.
It can be, but we've got this whole set of MBA materials, syllabi, lecture notes, bunch of other resources that you sent over.
Yeah, we're talking the full buffet.
Exactly. And I think our mission here, right, is to kind of distill all that down, give our listeners a solid understanding without totally overwhelming them, like the core principles, practical insights, all that good stuff. Ed, what do you think?
I'm in. And the materials are great, really. They cover everything, from the basics, what even is research, all the way to some pretty sophisticated statistical tests.
Yeah.
Like NOVAs and chi-square.
Yeah, I was glancing through the notes. There's stuff about field work, different ways to collect data, sampling, picking who to talk to, hypothesis testing, correlation, regression, and then even some non-parametric tests, which is a whole other world.
A whole other world indeed.
So, big question right off the bat, and this is for anyone who's maybe thinking, why do I need to know this stuff? In today's world, being able to really evaluate information, understand what data is telling you, making good decisions based on evidence, and it's crucial. It's not just for academics anymore.
Not at all.
No, it's for everyone. So if you want to up your game, understand how research works, how to interpret data, this is the place to be.
Absolutely. Let's dive in.
Okay, so starting point, right. Lesson 1. What is research?
Well, in a nutshell, it's this systematic way of searching for knowledge. Finding out about a particular topic. Now, your notes point out that social scientists, they define it in slightly different ways, like nuance. And
sure, they've got to make it complicated, right?
Right, of course. But the heart of it, right, it's about this academic activity that leads to new knowledge. That's the key.
And systematic is important there, I think. It's not just randomly Googling stuff.
No. It's got to be objective, structured, using proper methods of study, observation, comparison, experiment.
Like a recipe. You've got your ingredients, your steps.
Exactly. And it's all aimed at solving a problem or answering a question.
Right. So the syllabus, it lists out these broad objectives of research, like getting familiar with a new phenomenon, really accurately portraying its characteristics, figuring out how often something happens, and then this one that always feels a little bit intimidating, testing hypotheses about cause and effect.
Yeah, the why behind the what.
Yeah, exactly. So then the question becomes, why bother? Like, what drives people to do research in the first place?
Well, there are a bunch of reasons. I mean, some people, they do it for the degree, the credentials.
Fair enough.
But there's also, the pure intellectual joy of discovery.
Right, that aha moment.
Exactly. And then there's the drive to tackle real-world problems, right?
Right.
Make things better.
Make a difference.
Yeah, contribute to society. And I think the materials really stress that research, good, solid research, it plays a huge role in helping governments, businesses, organizations of all stripes make informed decisions.
Makes sense. Like, if you don't know what's going on, how can you make good choices?
Right. Garbage in, garbage out, as they say.
Exactly. Now, the notes also talk about different types of research, like basic versus applied, right?
Yeah, that's a good way to break it down.
So basic or fundamental research, that's all about expanding knowledge in general, like figuring out how things work at a fundamental level.
Okay, so like discovering the laws of physics.
Exactly. Whereas applied research, that's geared toward solving a specific practical problem.
So, like using those physics laws to build a better airplane.
Exactly.
Okay, so you've decided to do some research, right? You've got this burning question. Where do you even start?
Well, the materials really emphasize that the entire journey begins with identifying the problem. Like, what's the thing you're trying to figure out?
Well, you've got to be super clear about it.
Crystal clear.
Yeah.
Because, as the notes warn, any confusion at this stage, it's going to snowball. Like, you'll run into all sorts of problems down the line.
So a well-defined problem is like your compass, right? Points you in the right direction.
Okay, so you've got your compass. What's the next step?
Okay, so now you got to formulate researchable questions.
Yeah.
Like, how are you going to break down that big problem into chunks you can actually investigate?
And the notes are pretty specific about what makes a good research question, right?
Yeah, they lay out some key criteria. So the questions need to be clear, focused, concise, complex enough to be interesting. And this is a big one. Arguable.
Arguable?
Yeah, like there isn't an easy answer. It's something you actually need to do research to figure out.
Right, it's not just a quick Google search.
Exactly.
Okay, clear, focused, concise, complex, arguable. Got it. Now, the materials, they give some examples of how to take a broad question and make it more specific, right? Especially in the social sciences.
Yeah, they do. Like one example they give is, let's say you're interested in the effects of the internet.
Big topic.
Huge. But you can't just research the effects of the internet. It's too broad.
Yeah, where would you even start?
Right. So you need to narrow it down. Like maybe you ask, what's the relationship between daily social media use and self-reported anxiety levels among young adults in urban areas?
Okay, so you've gone from this gigantic nebulous thing to a much more specific question.
Exactly. And that's a question you can actually design a study to answer.
Right, you can measure those things, you can collect data.
Yeah.
So once you've got your research questions, the next step is figuring out your objectives, right?
That's right. Your research objectives, they basically translate those questions into specific aims. Like, what are you trying to achieve with this research?
And the materials are pretty clear about what makes a good objective, too.
They are. They stress that your objective should be measurable, achievable, realistic, and time-bound.
SMART goals,
Yeah.
basically. Specific, measurable, achievable, relevant, time-bound.
Exactly. So you need to know what you're trying to do, how you'll know when you've done it, and have a realistic plan to get there.
Okay, and the notes also distinguish between general and specific objectives.
Right. So general objectives, those state the overall aim of your research in a broad way. Specific objectives, they break that down into smaller, answerable questions.
Like subtasks, almost.
Yeah, exactly. And the notes also emphasize using strong action verbs when writing objectives, like to determine, to compare, to calculate.
Okay, so instead of to study, you say to analyze or something like that.
Exactly. Be precise, be specific.
Got it. Now, there's this other term in the outline, research gap. What's that all about?
The research gap. This is basically the missing piece in the puzzle. Like, what's the knowledge that's not there yet?
The unknown unknowns.
Yeah, kind of. It's the area where there's a lack of information, or maybe previous research had some limitations.
Or maybe the findings were contradictory and you need to figure out what's actually going on.
Exactly. And identifying this gap, it's super important because it justifies why your research is needed in the first place.
It's like you're saying, here's what we know, here's what we don't know, and my research is going to try to fill in that blank. Okay, so you've got your research questions, you've identified the gap you're trying to fill. Now you need data, right? The raw material of research.
Absolutely. Data is the fuel. And the materials, they define it as facts, figures, all those relevant bits of information that you're going to use to analyze and answer your questions.
And the notes break it down into primary and secondary data.
Right. Primary data, that's the stuff you collect yourself specifically for your research.
Fresh from the source.
Exactly. So this could be surveys, interviews, observations. You're gathering it firsthand.
Okay, and secondary data is what's already out there.
Right. Stuff that's already been collected and compiled. So like government reports, journal articles, existing data sets.
So primary, you're the detective, gathering clues. Secondary, you're using clues that someone else already collected.
Perfect analogy.
Now, the outline, it mentions a bunch of different ways to collect primary data.
Yeah, there's a whole toolkit. So there are focus groups.
Which are
Basically, you bring together a small group of people, and you have this guided discussion led by a moderator. You're trying to get their in-depth perspectives on a specific topic.
Okay, so a more qualitative approach.
Exactly. And then you've got observational studies where you're systematically watching and recording behaviors or events.
It's like Jane Goodall and the chimps.
Exactly. But, maybe with less climbing trees.
Hopefully. And then there are interviews, right?
Right. And these can be structured, like with a set list of questions, or unstructured, which are more free-flowing.
Or even over the phone.
Oh, yeah. Tons of ways to do it. And the notes talk about the pros and cons of each approach.
Right, like focus groups, you get rich data, but people might influence each other's responses. Observational studies, you see natural behavior, but you might not be able to control everything. And interviews, they can be time-consuming.
Exactly. And there's also the issue of bias, right? Like, how do you make sure you're not accidentally influencing the data you're collecting?
Right, good point. Now, questionnaires, those are another biggie when it comes to data collection.
Huge. Especially if you're trying to reach a lot of people.
Yeah, much easier than interviewing hundreds of people individually.
For sure. And the materials, they really stress the importance of good questionnaire design. Like clear questions, easy to understand, easy to answer.
Makes sense. If people are confused, your data's going to be a mess.
Exactly.
Yeah.
And you've also got to think about response rates. Like, how do you encourage people to actually fill out your questionnaire?
Right. If only 10% of people respond, your results might not be very representative.
Exactly.
Okay, so you've gathered your data. Now what? often you can't study everyone in a population, right? Like if you're interested in, I don't know, the opinions of all American voters, you can't interview every single voter.
No way. That's where sampling comes in.
Right, you pick a smaller group to study.
Exactly. And the goal is for that smaller group, the sample, to be representative of the whole population.
Okay, so you're basically taking a snapshot that reflects the bigger picture. And the notes introduce some key terms here. Population, sample, sampling frame.
Yeah, got to get those straight. So, population, that's the whole enchilada, everyone you're interested in.
Okay, so in our example, all American voters.
Right. And the sample is the specific group you're actually going to study, like maybe 1,000 randomly selected voters.
And then the sampling frame is...
That's the list or the source
Yeah.
from which you draw your sample. So in our example, it might be a list of registered voters.
Okay, makes sense. And there are different ways to actually choose your sample, right? The notes talk about probability and non-probability sampling.
Right. So the big difference is whether everyone in the population has a known chance of being selected.
Like if you're picking names out of a hat, everyone's name is in there.
Exactly. That's probability sampling.
Mm.
And it allows you to make stronger statistical inferences about the whole population.
Okay, because it's random, so it's more likely to be a fair representation.
Right. Non-probability sampling, it doesn't have that same random selection. So it might be easier and cheaper, but your results, you can't generalize them as easily.
Got it. Now, the notes, they give some examples of each type of sampling.
Yeah, like for probability sampling, there's simple random sampling. Everyone has an equal chance of getting picked.
Like the hat example.
Exactly. And then there's stratified sampling, where you divide the population into groups based on certain characteristics like age or gender, and then you randomly sample from each group.
Okay, so you're making sure you're getting a mix of people.
Right. And then there's cluster sampling, where you divide the population into clusters, like geographic areas, and then randomly select whole clusters to study.
Okay, so you're not picking individuals, you're picking whole groups.
Exactly. Now, for non-probability sampling, there's convenience sampling, which is basically just picking people who are easy to reach.
Like your friends and family.
Yeah, not ideal for generalizability, but sometimes it's what you've got.
Yeah.
And then there's quota sampling, where you try to get a sample that reflects the proportions of certain characteristics in the population, but without random selection.
Okay, so you're still trying to be representative, but it's less rigorous.
Right. And the materials, they also talk about how important it is to choose the right sample size.
Right. Too small, and your results might be fluky. Too big, and it might be a waste of resources.
Exactly.
Okay, so you've gathered your data, you've got your sample, now you need to make sense of it all. And this is where statistics comes in, right?
It does. And one of the key concepts here is hypothesis testing.
Which sounds a little bit intimidating.
It can be, but it's actually really powerful.
Yeah.
So essentially, hypothesis testing, it's a formal way of using your sample data to make decisions about the whole population.
Like testing your hunches using actual evidence.
Exactly. And you start by setting up two opposing statements, the null hypothesis and the alternative hypothesis.
Okay, break that down for us.
So the null hypothesis, it's basically saying there's no effect, no difference, no relationship. It's like the default assumption.
Yeah.
And the alternative hypothesis is what the researcher actually thinks is true.
So, like, if you're testing a new drug, the null hypothesis might be this drug has no effect on blood pressure, and the alternative hypothesis might be this drug does lower blood pressure.
Exactly. And then the whole point of the statistical test is to see if you have enough evidence to reject the null hypothesis in favor of the alternative.
Okay, so you're trying to prove the null hypothesis wrong.
In a way, yeah. And the process involves choosing a significance level, often called alpha.
Which is?
It's basically the threshold for how much risk you're willing to take of being wrong. A common value is 0.05 or 5%.
So you're saying I'm willing to accept a 5% chance that I'll reject the null hypothesis even if it's actually true.
Exactly. And then you calculate a test statistic and a p-value.
Okay, and those are?
The test statistic, it summarizes your sample data in a way that's relevant to your hypothesis. And the p-value, it's basically the probability of getting your results, or even more extreme results, if the null hypothesis were actually true.
So a really small p-value means it's super unlikely that you'd get your results if there was no effect.
Exactly. And if your p-value is less than your significance level, you typically reject the null hypothesis.
And the notes also mention these things called type I and type 2 errors.
Right. Those are the potential pitfalls.
Like where you make the wrong decision.
Exactly. So a type I error, that's when you reject the null hypothesis, even though it's actually true. It's like a false positive.
And a type 2 error is the opposite.
Right. It's when you fail to reject the null hypothesis, even though it's false, like a false negative.
Okay, so there's always a chance you could be wrong, but you're trying to minimize that risk.
Exactly. And your significance level, that's directly related to the probability of making a type I error.
Okay, now the lesson notes go into a bunch of different statistical tests. Z-tests, T-tests, F-tests, ANOV. It's a lot to keep track of.
It is. But the basic idea is that each test is designed for a specific situation. Like Z-tests and T-tests, those are often used to test hypotheses about the average value of a population.
Okay, so is the average height of women in this city different from the national average?
Exactly. And you'd typically use a T-test when you have a smaller sample size or when you don't know the standard deviation of the whole population.
And there are different types of T-tests, right?
Right. There are T-tests for looking at a single sample, T-tests for comparing two independent groups, and T-tests for comparing the same group at two different times.
Okay, so you choose the test that fits your specific research question.
Exactly. And then there's the F-test, which is used in ANOVA, analysis of variance, and is basically used to compare the averages of more than two groups.
So if you wanted to see if there was a difference in average test scores between 3 different teaching methods, you'd use ANOVA. Okay, that makes sense. Now moving on, the outline talks about correlation and regression.
Ah, yes. Measuring relationships between variables.
And those are different, right?
They are. So correlation, it basically tells you how strongly two or more variables are related.
Like, if you study more, your grades go up.
Exactly. That would be a positive correlation. As one variable increases, the other tends to increase too.
And a negative correlation would be like?
Like the more you exercise, the less you weigh. As one variable increases, the other decreases.
Got it. And the notes mention this thing called the correlation coefficient?
Right. That's usually represented by the letter R, and it ranges from -1 to +1.
So an R of +1 means a perfect positive correlation, and an R of -1 means a perfect negative correlation.
Exactly. And an R of 0 means there's no linear relationship.
And you can visualize correlations using scatter plots.
Right. Right. Each point on the scatter plot represents a pair of values for your two variables. And you can kind of see the trend. Like if the points are all clustered along a line going upwards, that's a strong positive correlation.
Okay, so correlation tells you if and how strongly things are related. What about regression?
So regression analysis, it takes correlation a step further. It tries to model that relationship, like create an equation you can use to predict the value of one variable based on the value of another.
Okay, so it's not just describing the relationship, it's trying to predict.
Exactly. And the materials, they mention simple linear regression, which is basically finding the best fitting straight line to describe the relationship between two variables.
So if you know the value of one variable, you can use the equation to predict the value of the other.
Exactly. Like if you know how much someone spends on advertising, you might be able to use a regression model to predict their sales.
Okay, so regression is super practical.
Very much so.
Now, last but not least, the outline mentions non-parametric tests. We've talked a lot about T-tests, ANOVA, all that. What are non-parametric tests, and when would you use them?
So non-parametric tests, they're basically your backup plan. Like if your data doesn't meet the assumptions of those other tests, the parametric tests.
Okay, what kind of assumptions?
Well, things like your data being normally distributed or having similar variability across different groups.
And if those assumptions aren't met, then
those parametric tests might not give you reliable results.
Okay, so non-parametric tests are more flexible.
They are. And they often work by analyzing the ranks or signs of your data rather than the actual values.
Okay, so they're less sensitive to those underlying assumptions.
Exactly. And the materials mention a few specific non-parametric tests, like the sign test, the Mann-Whitney test, the Kruskal-Wallis test, the chi-square test.
Can you give us a quick rundown of those? Like, when would you use each one?
Sure. So the sign test, that's often used for testing hypotheses about the median of a population. Like, is the median age of people in this town over 40?
Okay.
And the Mann-Whitney test, that's used to compare two independent groups when your data isn't normally distributed.
So, like, if you wanted to see if there was a difference in customer satisfaction between two different brands, but your data was kind of wonky.
Exactly. And the Kruskal-Wallis test, that's basically an extension of the Mann-Whitney test. It lets you compare more than two groups.
Okay, so, like, if you were comparing customer satisfaction across, say, 5 different brands.
Right. And then there's the chi-square test, which is used for analyzing categorical data.
Categorical data?
Yeah, data that falls into categories like gender or favorite color or yes-no answers.
So it's not numerical data.
Right. And you can use the chi-square test for things like goodness of fit tests, where you're seeing if your observed frequencies match what you'd expect.
Okay, so, like, If you flipped a coin 100 times, you'd expect roughly 50 heads and 50 tails. A goodness of fit test could tell you if your results were significantly different from that.
Exactly. And you can also use it for tests of independence to see if there's a relationship between two categorical variables. Like, is there a relationship between gender and preference for a certain type of music?
Makes sense.
And the materials, they even talk about how to calculate degrees of freedom for a chi-square test, which is important for interpreting the results.
Okay, we won't get into the weeds on that one. So, big picture, what are the key takeaways our listeners should walk away with?
Well, I think the main point is that research methodology and statistics, they provide this really structured and logical way to investigate questions, gather evidence, and draw conclusions about the world.
Right, it's not just about gut feelings or random guesses.
No, it's about being systematic, using data, and being aware of potential pitfalls.
And understanding these concepts, it really empowers you, doesn't it? Not just to do your own research, but to be a more informed consumer of information in general.
Absolutely. Whether you're reading a news article, evaluating a business proposal, or just trying to understand a scientific study, having this foundational knowledge, it gives you a huge advantage.
Right, you can cut through the noise and figure out what's really going on.
Exactly. And one of the fascinating things that emerges when you really start to think about how research works is how the choices you make along the way can really shape your findings. Like the specific questions you ask, the way you collect data, the statistical tests you use, all of that can influence the conclusions you draw.
It's like a chain reaction.
It is. And that raises some really interesting questions like, how do we ensure that research is as objective and unbiased as possible? How do we make sure we're not letting our own preconceived notions shape the way we interpret data?
Huge questions. And I think it really highlights the importance of critical thinking. Like, even when you're reading research that's been done by someone else, you can't just take it at face value. You've got to think about how they designed their study, how they collected their data, what statistical techniques they use.
Absolutely. And that's something I hope our listeners will take away from this deep dive. Don't just accept information passively. Question it, analyze it, and use your newfound knowledge to form your own informed conclusions.
Well said. Thanks for joining me on this deep dive. Until next time.